Prospectors miss gold not because it's rare, but because it doesn't look the way they expect. In floodplains, creeks, and roadside ditches, an unremarkable patch of dense black sand, often brushed aside, may contain fine placer gold, invisible without testing. Even when the gold is present, it's often locked inside or nestled between dark minerals like magnetite or ilmenite, camouflaged by their similar density and color. The real mistake is assuming that visible shine is the primary indicator. In practice, most field gold is matte, small, and surprisingly dull. That's why recognizing gold requires an entirely different kind of attention, less about color and more about behavior under pressure, gravity, and water flow. One of the most common locations gold hides is at the base of natural riffles, just behind a protruding rock in a stream or where a sudden drop in water velocity allows heavier materials to settle. In these pockets, gold mingles with heavies, magnetically active minerals that share its high specific gravity, roughly 19.3, which is nearly 10 times denser than quartz. What goes overlooked is how often this material collects in urban and suburban runoff zones as well: storm drains, culvert mouths, and erosion channels. These locations mimic natural placer traps but get dismissed because of their man-made appearance. Yet, the flow dynamics are the same. As water slows, the heaviest particles settle first. Gold doesn't care if the terrain is natural or engineered. It follows physics. A single handful of black sand from the right place can carry trace amounts of real gold, but few ever test it. The cost: often less than $1 for a magnet and a pan, or even just a kitchen sieve and a white plastic plate. The opportunity: a handful of finds that, multiplied over time, can reveal a reliable pattern or even point toward a larger deposit upstream. The crucial first step is learning what not to throw away. But how do you separate the promising black sand from worthless debris in the field, without lab tools or guesswork? The next topic introduces a dead simple magnet test that instantly filters your concentrate and reveals when gold may be hiding just behind the iron. Most black sands aren't worth more than the iron content they carry, but within them lies the key to finding gold, if you know how to sort them correctly. The simplest and most overlooked trick in field prospecting is the magnet sweep. With just a small neodymium magnet, readily available online or even scavenged from electronics, you can dramatically refine a pan of concentrates in seconds. It's not about finding gold directly with a magnet, but about removing what gold isn't. That distinction is everything. Magnetite and ilmenite are both ferromagnetic, meaning they respond immediately to a strong magnet. Gold, being diamagnetic and extremely dense, does not. When you've collected a pan full of black sand, running a magnet inside a thin plastic bag across the surface allows you to pull away the magnetic minerals cleanly. This bag method ensures your magnet doesn't get coated and lets you dump the filtered material safely without contamination. After this pass, what's left behind becomes exponentially more interesting. Non-magnetic black sands often include garnet, zircon, and, crucially, tiny gold particles. If any luster or flakes remain after the magnet sweep, they deserve closer scrutiny. This simple trick doesn't just clean your sample, it re-ranks your priorities. A pan that looked like a uniform dark mush suddenly reveals subtle color changes, layering, and fine particles with weight that resist movement underwater. The contrast becomes even clearer when the magnet sweep is done before panning. Doing so lightens the pan, increases your control, and allows gold, if present, to settle into its signature trailing edge in the riffles or at the lowest point of the swirl. This controlled behavior is diagnostic. Gold doesn't float off, and it doesn't stick to magnets. If something shiny disappears too easily, it's likely mica or pyrite. If it remains heavy and settles predictably, it's worth your time. This test alone eliminates most false positives in the field. It also saves hours by narrowing your effort to concentrates that matter. Even the best field test is useless if applied in the wrong location. Gold follows gravity, not maps, and understanding where it settles is the true starting line for any successful search. The simple trick of magnet separation only matters once you've scooped material from the right kind of trap, one shaped by water, time, and geology. That begins with reading terrain. Gold moves downstream until something forces it to stop. These drop points are usually found where a stream's velocity decreases, inside river bends, behind large rocks, below sudden gradient changes, or at the junction where a fast-flowing channel flattens into a wider pool. These are called depositional environments. While light sands and silt continue drifting, heavier particles, like gold, drop out and concentrate in subtle lines called pay streaks. Look for inside meanders with compacted gravels, armored layers, flat rocks stacked by flow, and areas with moss-covered bedrock. Moss, in particular, acts as a natural riffle, catching fine gold that floats just above the substrate. In arid or urbanized regions, ephemeral streambeds and culverts can mimic these natural traps. Roadside drainage ditches often feature riprap boulders or erosion barriers, which create similar low-pressure zones. If the upstream terrain includes exposed quartz veins, decomposed granite, or mineralized schist, the odds improve dramatically. These are common host rocks in gold-bearing regions, and erosion can carry fines for miles. Topographic clues are just as vital. When scouting new ground, contour maps reveal paleochannels, ancient riverbeds now dry but still capable of holding gold. These can sit dozens of meters above modern watercourses. Look for terraces with rounded cobbles or subtle trenches running parallel to present streams. These ghost rivers once carried gold-rich flows, now buried under soil and time. There's also the rule of 3, gold concentrates where heavy minerals concentrate. If your test pan consistently shows garnet, magnetite, or lead shot, you're in a gravity trap. If all you see is light sand and shell fragments, keep moving. A few good scoops in the right terrain, filtered with a magnet, can outperform hours of work in the wrong spot. Gold almost never travels alone. Wherever it settles, it does so in the company of other high-density minerals that act as silent markers, clues that the simple trick may soon pay off. Recognizing these companions transforms an average pan into a diagnostic tool, especially when the gold itself is too fine to see at first glance. What remains after magnet separation becomes a kind of geological fingerprint. The most common of these heavy indicators are magnetite and ilmenite, both strongly magnetic and typically removed in the initial sweep. Their presence in large quantities confirms you're in a gravity trap, a place where heavy materials concentrate. But it's what remains after the magnetic portion is gone that begins to tell the story of gold. First, garnet. Deep red to purplish or brown translucent grains with a glassy luster, garnet is moderately dense, 3.5, 4.3 Sg, and non-magnetic. It survives only in zones of hard erosion, and when it appears in pans, especially in conjunction with fine black sands, it's a solid sign that you're on the right track. The shape matters too. Rounded garnets suggest distance traveled, while angular ones hint you're close to the source. Next, chromite and zircon. Both are dense, unassuming, and often mistaken for grit. Zircon especially is notorious for showing up in gold pans as a false positive due to its high Sg, 4.6, and its bright sparkle under sun. But a simple scratch test or close loop inspection can differentiate it. Zircon is often prismatic and brittle. Gold is malleable and dense with no crystalline edges. If you're consistently seeing tiny, rounded, metallic-colored grains that don't move easily in the pan, you may be looking at gold or something very close to it. Lead shot is another unexpected but useful signal. It doesn't belong naturally, but if you find it embedded in gravel or mixed in moss, it means the site has held weight in previous flows. Gold behaves similarly in current and tends to settle nearby. Many experienced prospectors actually hope to find lead as a confirmation that their trap area has both the flow history and physical dynamics to capture precious metals. This is the moment where the pan becomes more than a tool, it becomes a narrative. The color, behavior, and layering of these residual minerals tell the story of water velocity, erosion source, and depositional history. When you start seeing consistent combinations, magnetite removed, garnet remains, trace metallic particles hugging the bottom, you're within reach of gold, even if it hasn't flashed yet. But how does this all tie into the actual trick? What happens in the moment you combine magnetic filtering with a single motion of water? In the next topic, we go step by step into the simple trick itself, the magnet sweep and swirl that leaves everything else behind. The simple trick to reveal gold in the field isn't folklore. It's a repeatable, physical separation process that costs nothing and exposes hidden value in seconds. It starts with a magnet, a plastic bag, and a pan of dark concentrate. When done properly, it isolates gold's two defining traits, high density and non-magnetic behavior. The result is a visual contrast that makes even micron-sized gold show up where it would otherwise vanish in black sands. Start with a full pan from a likely trap, inside bend, bedrock crack, or compacted gravel behind an obstacle. Wet the concentrate thoroughly to prevent dust loss. Now take a strong magnet, preferably neodymium, wrap it in a sandwich bag or a thin plastic layer, and hover it just above the surface of the pan. Don't drag it through the material. Gliding too deep stirs everything, muddying the sort. Instead, lift magnetite and ilmenite gently from the top layer, pausing to watch the response. You'll see the black sand leap upward in jagged clusters. That's your magnetic material gone, and with it, the visual clutter. Pull the magnet away, remove the bag, dump the magnetic grains, and repeat. After a few cycles, your pan will be noticeably lighter in volume, but what's left is exponentially more telling. Swirl the remaining contents slowly in a circular motion. Gold, due to its extreme density, 19.3 Sg, will migrate to the lowest point in the motion and resist being swept away. Look for dense trailing edges, flecks that move reluctantly or seem to crawl rather than slide. These are likely your targets. They won't react to the magnet, and they won't flash with a mirror-like sparkle unless they're sunlit at a precise angle. Matte, pale yellow, and heavy is more common than shiny and bright. If you're unsure, try the swirl hold. With water flowing, rotate the pan gently and then freeze. Watch what continues to slide. Gold will anchor itself even when everything else shifts. This behavior is diagnostic and one of the fastest ways to separate it from mica, pyrite, and other lookalikes. Pyrite might shimmer, but it skates across the pan. Gold doesn't. And this is where the trick's power shows. You've reduced the field of noise to only the most promising materials. In just minutes, using a $5 tool and a bit of technique, you've effectively accomplished the first stage of gravity separation, one that usually requires sluices or expensive gear. Gold behaves differently from nearly every other mineral in a streambed because of one defining trait: its extraordinary density. At approximately 19.3 grams per cubic centimeter, it's more than 6 times heavier than quartz, 2.65, and nearly twice as dense as lead. This isn't just trivia. It's the foundation of placer mining and the reason the simple trick works at all. When gold enters moving water, its weight means it settles faster, moves less, and locks into crevices and depressions where lighter particles would never stay. This density-driven behavior is what makes panning possible. As you swirl the pan, water lifts and carries away low-density material, clays, organics, and lighter sand grains. Medium-density minerals like garnet and zircon take more effort to move, but gold resists almost entirely. That's why, during the final stages of panning, especially after removing magnetics, the gold appears to cling to the bottom edge or trail behind in a tight line. It's gravity asserting its dominance. Understanding this movement is essential when assessing where to dig and how to pan. For example, in high-flow environments, gold often drops out immediately after a velocity break, like behind a boulder or at the base of a waterfall, while lighter material continues on. In low-flow systems, gold may only settle where bedrock is exposed, as the fine particles work their way down through layers of gravel and lodge in natural riffles or cracks. This is why mossy bedrock, potholes, and hardpan zones often contain surprising concentrations, even if the surface gravel seems unremarkable. In practical terms, gold's resistance to motion means you can use water pressure as a sorting tool. When you swirl the pan gently, gold stays. Increase the swirl force, and everything else moves, but gold remains. This lag behavior is your cue. Even with micron-sized gold, if you use clean water, reduced magnetics, and a steady swirl, the gold forms a halo or trailing edge that separates from all other components. This visual behavior is more reliable than color or luster. It also explains why gold concentrates build up in surprising places. Even in areas with little visible geology, such as desert arroyos or urban runoff channels, a single low spot can trap decades' worth of fine gold during flash floods. These deposits often go unnoticed unless someone tests the site with the right understanding of flow dynamics. The biggest reason newcomers miss real gold in the field isn't lack of effort, it's physics. Fine gold, especially particles under 100 mesh, 150 microns, behaves deceptively. Despite its extreme density, it often sits on the surface of water or slips away during panning. The culprit is surface tension, not weight. At that scale, even heavy metals can float if the water's cohesion holds them up. Many have unknowingly dumped gold back into the creek, thinking it was mica, pollen, or just debris that refused to sink. This is where the field reality of gold's behavior collides with intuition. Gold this small doesn't behave like visible nuggets or flakes. Instead, It looks like dull yellow dust or oily specks that drift when the water moves too gently. Without the right method, it will literally wash over the lip of the pan while heavier but coarser non-gold minerals stay put. And it's exactly this loss that the simple trick was designed to prevent. Once the magnet has cleared away the ferromagnetic noise and panning has reduced the bulk, the remaining fine gold, if present, may still be resisting visibility. The solution: a single drop of unscented dish soap or jet dry. Adding surfactant to your panning water breaks the water's surface tension, eliminating the float effect. In seconds, particles that previously skittered across the top now sink and settle, often revealing a ghost trail of real, recoverable gold you didn't even know was there. But the soap drop does more than force a reveal. It also acts as a confirmation mechanism. If shiny flakes persist in floating or spreading across the water's surface even after the surfactant is added, they're not gold. Mica, graphite, and certain silicates resist submersion due to their structure, not density. Gold has no such excuse. If it still floats post-surfactant, it's not gold. This is an elegant and immediate field test, one that costs almost nothing but protects against the most common form of misidentification. For those working in dry conditions or indoors, this same principle can be applied with a controlled water tray and a light swirl. Soap-treated water reveals fine gold trails even from heavily concentrated samples that looked barren under dry inspection. Some prospectors deliberately dry and reprocess tailings using this method after realizing how much fine gold their initial tests missed. The biggest clue to whether your method works isn't in what you keep, it's in what you throw away. After panning, most prospectors discard the leftover material without a second glance. But if any gold remains in those tailings, something went wrong. This quiet mistake is where real losses happen, often unnoticed. To test your own technique, go back to the pile of reject material, the part you thought was clean. Run it again through the same steps, wet it, swirl it, and observe. Gold, even in fine form, doesn't lie. It stays low, resists movement, and gathers in the same spots each time. If it reappears now, after you thought it was gone, it means your original pass didn't go deep enough or fast enough to separate it fully. Sometimes, gold clings to bits of clay or is trapped beneath heavier black sands that weren't thoroughly separated. The magnet trick helps, but it's not perfect if done too quickly. Even a single pass with fresh eyes can reveal the gold that got away, a reminder that haste, not technique, is often the enemy. This step is also where the difference between casual searching and serious prospecting emerges. Professionals test their tailings because they know gold is stubborn, and mistakes are expensive. Running the rejects gives you a second chance, and more importantly, teaches you what signs you missed the first time. But not all that glitters deserves a second look. In the next topic, we confront the most notorious deceiver in the field, pyrite. How do you avoid chasing a sparkle that leads nowhere? The answer lies in its behavior, not its color. Few things waste more time in the field than chasing pyrite. It flashes like gold, breaks the sunlight into bright glints, and hides in the same places. To the untrained eye, it looks promising. But in the pan, pyrite tells a different story if you know what to watch. Gold is soft and dense. Pyrite is hard and brittle. When you swirl the pan, gold settles low and stays still. Pyrite dances. It rolls, it floats briefly, and sometimes it shatters under pressure. This behavior is your clue. You don't need chemicals or machines, just careful observation and a steady swirl. In the sunlight, pyrite can seem brighter than gold. But its shine is sharp, like broken glass. Gold doesn't sparkle, it glows. It catches light softly, without flickering. If what you see flickers with every movement, it's probably not gold. Another sign lies in the shape. Pyrite often forms little cubes or sharp edges, while gold is usually rounded, as if shaped by time and water. Pick a piece up with tweezers. If it crumbles or snaps, it's not gold. Real gold bends. In the field, tiny differences separate a wasted day from a valuable find. When working with fine material, the surface of the water itself becomes part of the challenge. Even heavy metals can seem to float, not because they're light, but because of surface tension, the invisible skin that water forms when undisturbed. This is where many beginners lose their best chance. Fine gold, smaller than a grain of sand, can ride that tension and drift away before it's recognized. That's why one of the simplest, most powerful tests uses just a drop of plain dish soap. Adding a single drop of dish soap to your panning water breaks the surface tension instantly. It changes the way water behaves around small particles. Before the drop, you might see shiny flakes skating across the top, refusing to sink, slipping away with the slightest motion. After the drop, those same flakes must now either sink and settle, or float for a very different reason. Gold, when tension is removed, goes straight to the bottom and stays there. Mica, plant debris, and false indicators often continue to drift or swirl near the surface. This one step, invisible but decisive, tells you whether you're working with real weight or just a reflection. It's not about chemistry or making the water aggressive. The soap simply lowers the water's resistance to letting dense objects sink. That's all it takes to turn uncertainty into certainty. Fine gold, once hidden in floating confusion, now reveals itself in a slow glide toward the bottom of the pan. And it stays there. No matter how you tilt or swirl, it anchors itself, unaffected by minor movement. Another benefit is that it lets you work more confidently in marginal light or with less than perfect samples. When you know that nothing useful is floating anymore, you can focus all your attention on the base of the swirl. That's where real gold always ends up, collected against the edge, sitting low, resisting every distraction. It doesn't jump, it doesn't skip, and it doesn't shimmer like a mirror. Fieldwork thrives on simplicity that works. With the magnet already removing the false heavies, and the soap cutting through misleading surface effects, your remaining material is now a tight concentrate of what actually matters. But what if you want to go further? What if you want to know not just what stayed behind, but what didn't react at all? Once the water settles and the shimmer clears, you're left with a dense cluster of particles that refuse to float, refuse to flash, and refuse to move. But even now, not everything that stays in the pan is gold. Some heavy minerals, dark, metallic, stubborn, can fool even a well-trained eye if you don't separate them by behavior. This is where gravity meets magnetism, and understanding the line between the two reveals what might be gold, and what definitely isn't. By now, the magnet sweep should have removed the obvious players, magnetite and ilmenite, the two most common magnetic minerals in black sand. They're dense, dark, and show up in nearly every trap where gold might hide. But they're also highly magnetic, which makes them easy to pull with a simple pass. The real question is what's left behind after those grains are gone. That's where the gold, if it's there, should now be visible. The test is simple. After your pan has been reduced, take the magnet again and move it across the bottom slowly, close to but not touching the material. Watch what moves. If anything shifts or lifts, it's still magnetic. Remove it. Repeat until only the particles remain that do nothing in response. That's your non-magnetic fraction. And it's within that stubborn layer, barely moving underwater, that fine gold most often hides. Here's why it matters. Gold is non-magnetic. So is garnet, zircon, and a few other heavy minerals. But unlike gold, those others don't flatten, don't shine the same under soft light, and don't behave as predictably in the swirl. When you isolate the non-magnetic heavies and then slowly rotate the pan, gold tends to appear in very specific ways. It hugs the bottom, gathers in tight curves along the edge, and stacks behind itself in clusters or lines. No other mineral behaves quite like this in water. Even without lab equipment, you now have a reliable way to separate your materials into categories: magnetic and dense, non-magnetic and dense, light and floating. Gold lives only in one of those, the final pocket of non-magnetic, dense, low-mobility material. Everything else is either removed or ignored. Long after the noise is gone, after the lights, flakes, and magnetic distractions have been cleared, what's left in the pan isn't just material. It's a story. Each line, layer, and corner of the concentrate tells where the water has been, what it's carried, and whether you're close to something valuable. For the prospector who knows how to look, the pan becomes a topographic map in miniature, each particle marking flow, weight, and time. The first layer to watch is color. Even among black sands, shades differ. Deep, matte black may signal dense magnetite, while reddish tints suggest iron-stained minerals like garnet. A subtle sparkle, not bright but earthy, may come from zircon or rutile. These colors appear in arcs or thin streaks, sorted by the motion of water and the relative density of each mineral. When those streaks repeat, same order, same curve, it's not random. It means the flow is stable and strong enough to sort heavies by weight. That's when gold usually follows. Next is position. Gold doesn't sit on top. It works its way to the lowest point in the pan, often hugging the outer edge if you're swirling, or pooling in the very bottom corner when you tip the pan slightly. If you see a pattern forming there, a few consistent particles that appear every time, even in new scoops, you're on the edge of a pay zone. These aren't just isolated finds. They suggest a nearby source, feeding tiny bits of gold over time. Another detail lies in particle shape and arrangement. When gold is present, especially in fine form, it often lines up behind other gold. It stacks. It clusters. Unlike light minerals, which scatter, or magnetic ones, which jump, gold behaves like a liquid in slow motion. It flows, pools, and rests exactly where water would push it, and then stays there. If your swirl reveals particles trailing in a tight line or forming a crescent at the base of the pan, you may be looking at more than coincidence. Reading this visual map isn't just about knowing what's there, it's about knowing what to do next. If every pan from the same spot tells the same story, you're in a repeatable deposit zone. That's when you stop scouting and start recording. Grid the area. Note the angle of the slope, the depth of the layer, the position relative to bedrock or boulders. The pattern is your proof. Gold doesn't require luck, it requires a system. The mistake most people make is treating each new spot like a blank slate, guessing their way through it with no structure. But once you've learned to read terrain, remove the false indicators, and watch how materials behave underwater, what you need next is consistency. A repeatable method. A field workflow that gives every new location the same disciplined approach, no matter where you are. It begins with choosing the right spot. Not just where the river looks good, but where you've already seen signs, inside bends, moss-covered bedrock, or gravel bars below a drop. Take a sample, just one pan's worth at first. Wet it thoroughly, then do a slow pass with your magnet wrapped in plastic. Remove all magnetic black sands before you pan. This lightens the load and clears visual clutter before you even start to swirl. Swirl slowly. Watch how the remaining material behaves, and make your first judgment based on movement. Dense particles settle low, hold steady, and resist current. Watch for fine trails, subtle weight, or anything that clings to the curve of the pan when everything else slides. If you see this, test again from the same spot. Consistency means you're not chasing a fluke. Once you get 2 or 3 pans showing the same traits, non-magnetic heavies, tight concentrates, reluctant movement, it's time to mark the area. This doesn't require high tech. A stick in the bank, a GPS ping on your phone, or just a photograph of the zone is enough. The goal is to build memory. What layer you scooped from, what the terrain looked like, and how the gold responded. From here, step back and test adjacent zones. A few meters upstream, downstream, or toward a side channel. Use the same workflow each time. Don't change the method unless the results demand it. This repeatability builds trust in your results. It also helps you identify patterns over time, where gold tends to collect in that specific landscape. As the pattern becomes clearer, increase your sample volume. Move from single pans to bucket loads. Classify with a screen to remove large rocks. Use the same magnet pass, then pan small portions of the concentrated material. Track your success by what remains at the bottom. This is the stage where efficiency meets patience. Rushing leads to error. Repetition reveals value. This system works in rivers, creeks, arroyos, dry washes, even roadside ditches with the right geometry. It's not about gear, it's about observation, consistency, and trusting what the materials show you. Once you've seen repeatable results, the next step isn't deeper digging, it's smarter sampling. Once a pattern starts to show, gold in multiple pans, repeated signals across the same stretch of terrain, it's time to shift from curiosity to structure. Sampling at random might get you lucky once. Grid sampling ensures you don't miss the bigger picture. This is the step where the hobby becomes a method, where small hits become part of a map, and where the difference between a scatter of finds and a workable deposit starts to emerge. Gridding doesn't mean high-tech surveying. It can be as simple as using flagged stakes, small markers, or natural landmarks to divide a promising area into clear zones. The key is consistency in spacing. Each sample should come from roughly the same depth, the same layer type, gravel, clay, or bedrock contact, and the same volume. Don't change your pan or bucket size mid-process. The goal is to compare results across space, not guess at randomness. Start with a central point, where your best pans came from. Mark that as your origin. Then move outward in straight lines, upstream, downstream, toward the banks. Keep your distances even, 2 strides, for paces, a measured stick. Every location gets its own sample, its own magnet test, and its own pan. Keep the process identical across the grid. Only then can you compare honestly. As the results come in, patterns start to form. One edge may show nothing but light sand. Another might deliver increasing amounts of non-magnetic heavies. If multiple samples within one section show gold behavior, settling low, resisting swirl, consistent particle traits, you've identified a concentration zone. That's the part you focus on next, tightening the grid, increasing sample density, and watching how the gold behaves across it. It's also at this stage that many prospectors make a critical mistake. They chase the visible color too quickly. But what matters more than a single shiny flake is repeatability. A streak of finds that appears in every pan across a 10-meter line is more valuable than a one-time flash. Gridding reveals whether the gold is scattered or clustered, moving or locked, shallow or deep. And the data tells you more than location. If the gold gets richer closer to bedrock, you may need to dig. If it sits in mossy riffles, you can surface harvest. If it trends toward a buried channel or side cut, the deposit may be ancient, not modern. Each clue you record becomes part of the deposit story, and your decision about what to do next. In the field, after color tricks and water behavior have all played their part, one truth remains: gold feels different. Long before testing kits and conductivity meters, miners trusted something primal, the weight in the hand. Even the smallest piece of real gold gives itself away through mass. It resists flicking, settles instantly, and presses down with a density nothing else can fake. This is the final test before lab work. A human test. One that doesn't need numbers to speak clearly. It starts with experience, yes, but it can be trained quickly. When you hold a small scoop of concentrate, maybe a few tablespoons, there's a moment where the heft surprises you. If most of the visible grains are black sand or garnet, and yet the material presses into your palm like lead shot, pay attention. You've found a pocket rich in heavy minerals. Gold may not be visible yet, but something dense is here. And when the shimmer is gone, weight is your compass. This works especially well with dried concentrates. After you've panned and magnet swept, letting your remaining material dry completely gives you a clean sample. Pour it into a small vial or film canister. Shake it. Listen. It won't rattle like quartz or mica. It will thud, sink low, press heavy for its volume. And in time, you'll feel when something is missing, that expected weight is gone, and you know the difference. Comparative testing also helps. Carry 2 small vials, one with known garnet or black sand, one with a suspected gold-bearing mix. Without looking, pick them up and feel. The one with gold won't just weigh more, it will shift differently, settle faster, and feel denser even when swirled with your fingers. It's not a precise measurement, but it's a reliable one. That physical sense of mass separates illusion from value. Even wet material offers clues. When swirling the last bit in your pan, if certain particles sink instantly with a satisfying thunk while others hover or swirl longer, you're feeling the gold's presence. It moves slower but stops faster. It drags the swirl. It ends up always in the same place, bottom corner, edge pocket, lowest dip. This kind of feedback doesn't show up in photos. You can't share it in forums. But it's what experienced fieldworkers rely on most. The eyes can lie. The weight doesn't. And once the weight confirms what the color and behavior suggested, the next move is clear. Increase volume. When the pan confirms the weight, the behavior, and the pattern, it's time to move beyond testing. The moment a site gives repeatable signs, gold that appears consistently, concentrates that feel heavy, non-magnetic fractions that show color or settle in patterns, you've outgrown the pan. The next step is to scale up, not by guessing, but by bringing in gravity's best tools, the battee and the sluice. The battee, a wide, shallow dish often made of metal, predates the modern pan. It's favored in parts of South America and Africa for one reason: it processes more material faster. Its broad surface allows for finer control of water and swirl, and because there are no riffles, It gives you full visibility of how your concentrates behave. The technique is different. Instead of tilting and scooping, you spin the water in smooth circles, letting the material stratify and the gold settle into the center. Once you've trained your eye, a battue lets you test high-volume samples from a promising site with remarkable speed and precision. But if you're working a stream and want even more throughput, the sluice is your next move. A simple aluminum or plastic chute lined with riffles, the sluice uses flowing water to separate gold from lighter material automatically. You feed in classified gravel from the top, and the water does the rest. The riffles create small eddies, backflows that allow heavy particles to drop and settle while lighter sands wash away. Gold, being the heaviest, gets caught behind the riffles and holds. Placement is everything. A sluice must sit at the right angle, not too flat, or it clogs, not too steep, or it loses gold. A gentle slope and consistent water flow are key. You want the sluice to clear lighter materials while giving gold just enough time to drop. Testing different angles for 5 or 10 minutes at a time reveals what's working. A well-run sluice can process dozens of pans worth of material in under an hour. The biggest advantage of both tools is efficiency. With the battue or sluice, you're no longer sampling, you're producing concentrate. And with every run, you get a clearer picture of how rich the deposit really is. Are you seeing a few fine specks per bucket? Or a noticeable buildup behind each riffle? Does the gold appear in every load, or does it taper off as you move downstream? No matter how skilled your fieldwork becomes, there's one final threshold before any claim holds weight beyond the creek: lab confirmation. A pan full of fine gold may look promising, but markets, buyers, and even licensing authorities won't take visual evidence alone. You need data, measurable purity, weight, and content. And that means choosing the right test. In small-scale prospecting, two options dominate: fire assay and electronic analysis. Each has strengths, costs, and ideal use cases. Knowing which to use, and when, can save you both money and credibility. Fire assay is the oldest, most reliable method for determining gold content. It involves taking a known quantity of your sample, usually in grams, melting it with flux in a high-temperature furnace, and separating out the metal content by chemical reduction. What remains is a tiny bead of pure metal, often gold or a mix of gold and silver, called a prill. The lab weighs this prill and calculates the gold content relative to the original sample. It's precise, respected, and considered the standard by most official channels. However, fire assay is destructive. Your sample is consumed in the process. It also takes time, anywhere from a few days to a couple of weeks depending on lab demand. Costs vary but are often reasonable for small batches. If you're serious about a site and want to document its grade per ton, this is the go-to test. It can confirm whether a deposit is just a curiosity or holds enough concentration to justify further investment. For quicker reads or rough screening, electronic methods offer another route. Handheld XRF, X-ray fluorescence, analyzers can scan a sample and detect gold and other metals on the spot. These devices measure the secondary X-rays emitted by materials when exposed to high-energy primary rays, identifying elements based on their energy signature. The results are nearly instant, but they have limits. Electronic scans work best on solid pieces or concentrated, dry samples. They can miss ultrafine gold or underestimate values if the sample isn't uniform. They also only scan the surface. Gold locked inside rock won't register unless exposed. That's why electronic testing is best used for nuggets, visible veins, or quick checks before sending a sample for assay. Think of it as a filter, not a proof. Some labs offer ICP, inductively coupled plasma, tests or other advanced spectrometry options, but for most field finds, fire assay remains the gold standard, especially when filing a claim or seeking buyers. And whichever test you choose, it's best to send duplicate samples, keep a chain of custody, and request a breakdown by metal type. The results don't just confirm gold, they reveal how much silver, copper, or trace elements might be present, which can affect both value and extraction method. Not all gold is valued equally, and nowhere is that more apparent than in the world of fine placer gold. Even after lab confirmation, the actual worth of your find depends not just on purity and weight, but on form, recovery cost, and market perception. Understanding how fine gold is priced, and where the profit margins shift, is the difference between a pocket of glitter and a viable deposit. Fine placer gold, especially particles smaller than a grain of sand, is typically sold by weight. But the price per gram or ounce isn't based on spot market numbers alone. It's discounted.
Why?
Because fine gold requires extra processing to refine. It often contains trace silver or other metals. It may be coated with oxidation, hard to melt, or mixed with silicates. For the buyer or refiner, this adds labor. That cost is passed back to you. The purity matters too. If your fire assay returns a high percentage, say over 90%, your gold is more attractive. But even then, the form plays a role. Nuggets, flakes, and coarse pieces are often sold at a premium, especially to collectors or jewelers. They're rare, recognizable, and don't need smelting. Fine gold, on the other hand, especially flour gold, is harder to verify on site. It must be cleaned, weighed carefully, and usually melted down before resale. Buyers adjust for that risk. They pay less per gram unless your sample is accompanied by proper assay paperwork and has been dried, cleaned, and sorted. This is why many small-scale prospectors opt to build up their concentrate over time, then sell in bulk to refiners who accept raw material. Bulk deals often yield better returns, even if the price per gram is lower, because the cost of shipping, smelting, and assay is spread over more material. Location also influences value. Gold from known historical areas, famous rivers, old districts, can carry added value due to provenance. Some buyers pay more for material with a traceable story, especially if it comes from a respected claim or a documented geological zone. Others simply want clean, consistent supply, and prefer fine gold with reliable specs. This is also where ethical considerations come into play. Gold from unregulated or questionable sources may face scrutiny in certain markets. Being able to demonstrate your sampling process, safety, and compliance, even on a small scale, helps maintain trust and opens doors to higher-paying buyers. Ultimately, the path you choose, selling raw concentrate, melting for bars, or working with a local buyer, depends on volume, purity, and your own goals. But one thing's certain, without understanding the market, even good gold gets undervalued. And worse, in a world full of eager buyers, not all of them are playing fair. In the next topic, we expose the traps and tricks that can make a legitimate discovery feel like a loss. From salted claims to lowball offers, knowing the signs of fraud protects your work and your wallet. Even with all the right methods, a prospector can fall victim to one of the oldest games in the trade, fraud. Whether you're buying a claim, partnering with a seller, or even just evaluating samples from another site, the threat of tampered evidence is real. And it often starts with a sparkle that's just a little too obvious. Gold fraud doesn't always involve fakes, it often involves something far more convincing, the truth, planted in the wrong place. The most common trick in the field is the salt job. A seller sprinkles fine gold into a sample pan, a moss pocket, or even directly into a hole drilled into the bedrock. When a buyer arrives and runs a test pan, real gold appears, shiny, dense, resistant to swirl, and the illusion is complete. But that gold didn't come from the land. It was seeded to sell the story. In other cases, fraud takes the form of gold-painted sand. Fine grains of pyrite or silica are coated with metallic paint or dusted with real gold powder. These fakes are harder to spot when wet, as they mimic the soft gleam of genuine particles. But under dry inspection or under magnification, their flaws show: flaking surfaces, inconsistent shapes, and a greasy shimmer that doesn't behave like true metal. To guard against these traps, rely on process, not performance. If a sample only produces gold once, and never again in follow-up pans, that's your first warning. Real deposits show consistency. They behave the same way across multiple samples, depths, and locations. If the gold seems too coarse for the terrain, or appears in an otherwise barren matrix, pause. Ask yourself if the geology matches the result. Chain of custody also matters. Never buy or evaluate a site without controlling the sample yourself. Bring your own tools. Choose the dig spot. Sift and test in real time. Don't accept pre-bagged material or test pits dug in advance. Anything you don't personally verify is open to manipulation. Even lowball offers, where someone claims your gold is worthless due to low purity or processing cost, can be a type of fraud. A buyer may undervalue fine placer gold, especially if you haven't verified purity with a lab. They rely on confusion and urgency. That's why having even a basic assay result in hand gives you leverage and shuts down many bad actors instantly. The good news is that fraud can't survive scrutiny. Real gold behaves a certain way. It's heavy. It resists motion. It stacks. It doesn't flake or shine like foil. And it doesn't vanish when you return to the same spot. Once you know the signs, the tricks become obvious. But the strongest defense is evidence. In the next topic, we revisit the concentrates with a side-by-side test, magnet pass, soap drop, and swirl, to show exactly how real gold behaves in contrast to everything else. Nothing beats a direct, visible result. And when you see it, you won't forget it. Even the smartest method falls apart if you're testing in the wrong place. Not because of geology, but because of law. Gold might be there, but if you're not allowed to collect it, keep it, or even pan for it, your effort can turn into a fine or worse. That's why knowing where the simple trick can be used legally is just as critical as knowing how to use it. Fortunately, there are many public and private lands where responsible prospecting is allowed, if you know how to find them. In many countries, public lands include areas open to recreational prospecting. These are typically managed by government agencies or forestry departments and include rivers, streams, and gravel bars where hand tools, pans, and non-motorized gear can be used without permits. These areas are ideal for magnet pass and swirl testing, as long as you follow posted rules. Often, there are limits on digging depth, volume moved, and disturbance to vegetation. You're allowed to look, but not strip the landscape. In other cases, public lands may fall under free use or casual use designations. Here, individuals can sample, pan, and even sluice in moderation, provided they're not using heavy equipment or chemicals. Some regions even issue day permits or seasonal licenses for small-scale gold recovery. These are excellent options for using the trick in real terrain with real permission. Local geology guides, mineral maps, or online forums often list these spots with GPS coordinates and access info. But not all promising sites are open. National parks, nature reserves, and designated heritage zones often prohibit any form of collection, even surface-level panning. Even if you see a perfect bend in the river with black sand glinting in the sun, if the land is protected, it's off-limits. The same goes for tribal or indigenous territories, which may require direct permission from governing councils or local representatives. Respect for these areas isn't just legal, it's ethical. Private land opens a different opportunity. If you know the owner and secure written permission, you can test, sample, and even recover with greater freedom. This is where many overlooked sites thrive: old floodplains, unused pastures near mineral belts, or historic drainages long forgotten. A simple letter or handshake agreement can grant you access to untapped ground where the simple trick may reveal finds in every handful. Urban runoff areas, such as culverts, drainage ditches, and storm channels, present a legal gray zone. Technically, they're often managed by municipalities or transportation departments. Small-scale sampling might be tolerated, but any digging or disruption could bring attention. The best practice is discretion, minimal disturbance, and respect for public infrastructure. Never block flow, damage surfaces, or leave debris. If approached, be ready to explain your process and clean up without argument. Knowing where you stand legally frees you to focus on the process. When access is clear, you can test with confidence, sample deeper, and document results. It also allows you to build long-term relationships, landowners, local clubs, or forestry contacts, who may open doors to more promising ground. And sometimes, those doors reveal more than you expect. In the next topic, we follow what happened when this method was used on a site believed to be tapped out, and how a few overlooked indicators brought a long-forgotten claim back to life. 4 years, the claim sat idle, just another overworked stretch of gravel above a narrow stream, remembered only by rusted cans and faded markers driven into the dirt. Locals said it had been panned clean decades ago. Some remembered dredges there in the 50s. Others didn't bother with it at all. The gold, they said, was long gone. But the landscape hadn't changed: a sharp inside bend, exposed roots gripping bedrock, and a low flood terrace just beyond the bend. To most, it was spent. To someone with a magnet and a steady swirl, it was unfinished business. What changed everything was a single afternoon and the simplest test. A small magnet swept through the first pan pulled from the base of an alder tree. The black sand was thick, heavy, and eager to climb the plastic. After a few careful passes, the pan was cleaned to its dense, non-magnetic layer. A slow swirl revealed something odd, a faint line of dust-colored flecks, duller than glitter, heavier than sand, collecting at the base and refusing to move. A second pan confirmed it. A third made it undeniable. This wasn't just random color, it was fine gold. It had always been there, just masked by iron and clay and passed over by people looking for flakes or nuggets. Over the next week, a methodical grid sampling of the terrace revealed a narrow ribbon of pay dirt less than a meter deep but dense with fine gold, more consistent than anything nearby. It wasn't rich by historical standards, but it was enough. Enough to bring attention back to the claim. Word spread, not because someone found a fortune, but because someone proved it still had value. The previous owner, long thought to be sitting on dead land, reclaimed the site with renewed focus. With minimal disturbance and hand tools, they began a new sampling campaign. No excavators. No noise. Just quiet, careful collection. The land responded well. Local clubs took interest. Students came to observe the process. A small group partnered with the claimant to collect data and test other overlooked corners. Within 6 months, an old site once written off became a teaching ground, a proving ground, and a quiet source of steady return. Not for glory, but for knowledge and respect. The impact rippled outward. Other claims once dismissed as barren were revisited. Techniques sharpened. And in the center of it all was the method, the magnet sweep, the patient swirl, the density behavior. That started with one pan and a willingness to question the assumption that it's already been worked. It proves that even forgotten ground, when seen with better eyes and better process, can still yield something valuable. And sometimes, what it yields isn't just gold. But the clearest evidence always lies in the side-by-side comparison, the exact moment where fake falls away and real gold settles into place. In the next topic, we watch that moment unfold. Black sand, magnet cleared, swirl set, and the truth revealed in motion. Nothing settles doubt like watching two pans swirl side by side, one a mixture of deceptive shimmer, the other revealing real gold with quiet certainty. It's the moment where theory becomes visible, where movement and behavior expose what color alone cannot. In the field, this test becomes the final word. No need for argument, no need for guesswork. You see the difference with your own eyes. The first pan, pulled from a location with promising glint but inconsistent indicators, looks lively. Under sunlight, flakes dance across the water. They catch every beam, throwing flashes that seem too bright, too eager. When the magnet sweep is applied, nearly half the material leaps up, revealing a residue of silvery, paper-thin fragments. They swirl rapidly, scatter with the slightest tilt, and refuse to settle into a single corner. They dazzle, but they move too easily. A drop of dish soap confirms it. Many of them stay afloat, skating on the water's surface. Not gold. Mica, pyrite, and silicate fragments, lightweights wearing the costume of value. Now the second pan. It begins with heavier black sands, sticky in the bottom, reluctant to lift. The magnet clears the top layer, revealing a more compact, darker base. A slow swirl starts, and in a few rotations, a fine ribbon begins to form. Not bright, not flashy, just a soft, dull yellow line hugging the pan's curve. It doesn't move unless forced. When forced, it resists. Drop after drop of water rolls over it, but it stays low, anchored. A subtle tilt pushes the lighter grains out, leaving that same quiet streak behind. Soap is added. There is no drama. No particles float. Everything sinks, clean and final. And at the very base, what looked like nothing begins to shine, not like a mirror, but like metal. That warm, weighty glow that only gold produces. Not an illusion. Not a trick of light. Gold that holds its ground when everything else slips away. This moment, when both pans are seen together, teaches more than a dozen lectures. Because gold always reveals itself in how it behaves, not just how it looks. The tests aren't just tools, they're a language, and gold speaks fluently in silence, in density, in gravity. And now that you know how to find it, test it, and prove it, one question remains. What do you do next? Do you keep the gold, process the claim, or take it to someone who can? The next topic explores what paths are open once the truth is in your pan, and what choices make sense depending on your goals.